Section 3.1 deals with radian measure. Radian measure is an alternative to degree measure. It's just a second way of measuring angles. Just like I can measure time in either minutes, hours, or a combination of both. So when we deal with angles, we can measure them in degrees or we can measure them in radians. And from now on, you need to be really careful when dealing with an angle and make sure you know whether it's in degrees or radians and treat it as such. Let's see if we can figure out what a radian actually is. Now, degrees are made up. We talked about it earlier, the Babylonians decided a very long time ago that there were just going to be 360 degrees in a complete revolution of a circle, and that we were going to divide that up, and one of those, 1/360th of that, is what a degree is. A radian, however, is built into the concept of the circumference of the circle. So here's what it is. If we take a center, the center point of the circle, and we measure an angle that has the equal arc length along the circumference as the radius of the circle, that angle has a measure of 1 radian. That's what a radian is. It is the measure of the angle that is formed when we set it up so that it has the same radius and arc length of the circle. So for example, this is 1 radian. So about the same amount of that would be about 2 radians. And if we went all the way over here, that would be 3 radians. So radians are a lot smaller. They're, a little more than 3 radians in 180 degrees. So you kind of have to keep your mind wrapped around that. We're going to spend a lot of time and effort, especially early on, converting between degrees and radians. So we've already learned how to convert degrees to decimal degrees and degrees, minutes, and seconds. But now we're talking about moving into an entirely different unit. Sort of like when we learned to convert kilometers to miles or miles to kilometers. And you do need to know these conversion factors for the remainder of the semester and hopefully for the remainder of your life. Okay, so converting between degrees and radians. Here we go. If you want to convert something to radians, you multiply by a conversion factor of pi over 180. That's how you convert to radians. If you would like to convert to degrees, you multiply by 180 degrees over pi. So you just multiply by the reciprocal. So if you can remember 180 and pi, most people can usually figure out from there which one goes on top based on which of the units you would like to cancel. So one more time. If I want to convert 2 radians, I multiply by pi over 180. But if I want to convert to degrees, I multiply by 180 over pi. So let's take a look at some of these examples. For our first example, we would like to convert each degree measure to the appropriate radian measure. And if I don't tell you otherwise, what I would really like for you to do is to leave the radian measures exact. That means don't turn them into a decimal, leave them as a fraction. So let's take 45 degrees. If I start with 45 degrees and I want to convert it to radians, I need to multiply by pi over 180. So we'll start here and we will multiply, and we'll kind of do it the same method as we do dimensional analysis in chemistry and see if that helps you out a little bit working with the fractions. We'll multiply by pi over 180 degrees. Now the nice thing is that the degrees cancel. So degrees are gone and we're left with just radians. That gives us 45 pi over 180. Now here's where a lot of students go wrong. They want to turn the whole thing into a decimal, but you can't do that. I asked you to leave it exact, and pi is an irrational number. So once you type it into your calculator, you can't turn it back into a decimal. So what you need to do is reduce only the coefficients, the 45 over 180. And if we look at that, 45 actually goes into 180 4 times. So this actually reduces to what we call 1/4 of pi. Now, I actually prefer it written that way, like just myself, it means more to me, but for some reason in trig, we always do it as simply pi over 4. So that's how we're going to leave our answer, pi over 4. So we have just learned that 45 degrees is equivalent to pi over 4 radians. And as it turns out, there is no symbol to indicate radians. The pi doesn't necessarily indicate radians. You could have just 2 radians, so you don't have to have a pi to indicate radians. So you have to understand that if there is no unit, the angle is assumed to be in radians, whether there's a pi or not. If I put the whole thing into my calculator, and I'm going to do that right now, I can turn it into a decimal, and it's still radians, and I could round it, and I will just round it to 3 decimal places. So when I type that in and round it, I get 0.785 radians. So those are approximately equivalent there. This one is exact, whereas this one right here is an approximation. So only approximate when I ask you to. Most of the time, just give your answers as exact fractions, and a lot of times they will contain pi. Okay, let's look at negative 270 degrees. Negative 270 degrees multiplied by pi over 180. Cancel the degree marks, and we're really left with negative 270 pi over 180. Well, if we reduce negative 270 divided by 180, that should reduce down to negative 3 pi over 2. Negative 270 over 180 reduces to negative 3 over 2, and we just leave the pi on top. So negative 3 pi over 2. So negative 270 degrees is equivalent to negative 3 pi over 2 radians. Another way we could say that it's 1.5 pi, or negative 1.5 pi. If we wanted to turn that into an actual decimal, including the pi, now we could type into our calculator negative 3 times pi divided by 2. And that would give us about negative 4.712 radians. And finally, we have 249.8 degrees. Let's multiply that through by pi over 180 degrees. Let's cancel our degrees. And right now it looks a little weird. We have 249.8 pi divided by 180. So I definitely can't reduce that or simplify that without my calculator. So I'm going to type in 249.8 divided by 180. Remember not to type the pi in right now. We want to leave it as a fraction, and we can't do that if we enter the pi. All right, if I convert that to a fraction, I get 1,249 over 900. So that's how many radians that is. If I want to convert that to a decimal, we just type that in our calculator and multiply it by the pi. And that gives us 4.360 radians. And that's how we convert from degrees to radians. Okay, so I'm sure you knew this was coming. Now that we've gone from degrees to radians, we want to make sure we can go the other way, that we can go from radians to degrees. So let's take a look at 9 pi over 4 radians. So we have 9 pi over 4, and I'm going to multiply that by my conversion factor, which in this case, I want to go 2 degrees. So degrees are going to go on top, 180 degrees over pi. And the nice thing is in this case, the pi's cancel, and we can just figure out what that leaves us with. We have 9 times 180 which is 1,620 over 4, and that will simplify to 405 degrees. I kind of like to go this way because we're not usually left with any fractions, and when you're dealing with a degree measure, it's preferable to have it in a decimal form, even if you get one. So I just kind of like to go from radians to degrees better than from degrees to radians. Let's take a look at negative 5 pi over 6. Negative 5 pi over 6 multiplied by our conversion factor of 180 degrees divided by pi. Once again, because we had a pi in the original and a pi in the denominator of the conversion factor, the pi's cancel to 1, leaving us with negative 5 times 180 divided by 6. So negative 900 divided by 6 gives us negative 150 degrees. So those are pretty easy. Most people don't have any trouble with that. Here's where sometimes people get a little confused. We have 4.25 radians. Notice that it was given as an approximation. It wasn't given to us in terms of pi. Radians don't have to have pi in them, but most exact radians do. But not everything is an exact number, so it's okay to just have it as a decimal. 4.25 radians. We're going to multiply it by a conversion factor of 180 degrees over pi. The problem here is that nothing cancels. But that's okay. We just multiply top by top, bottom by bottom. The top gives me 765 divided by pi. Now occasionally the ACT will leave it like that. I've seen them do that before where you have 765 degrees over pi. Or actually, I guess I should write it like this, 765 over pi degrees. And that would be okay. But for us, we don't really have any concept of what that is, so let's go ahead and just convert that to an actual decimal. So let's see what 765 divided by pi actually is. I got 243.507 degrees. 243.507 degrees. So just pay attention to your directions and see whether they want you to leave them as exact values or rounded decimal values. In this case, I didn't have a choice. I had to either leave it as 765 over pi, which kind of bothered me, or rounded. I wasn't told what to round to. I suppose I could have done significant digits there, but just for the sake of learning, I thought we would carry everything out to 3 decimal places. And so that's all there is to it. That's what a radian is, and this is how we convert between degrees and radians. I think that's a really good place to break, and then we'll start talking about some of the common radian measures that you really need to know from memory, or you need to know so well that they just become second nature to you.